Okay, so hello and welcome to another Easy Happy Hour session. That is every Monday between 2 and 3 p.m. Today we are in the topic series of Easy Fundamentals Refresher. The current session is Meet Easy, Build Once, Run Everywhere. So the aim of this topic series is to do a quick review over several previous Easy Happy Hour sessions and also about easy topics covered during the previous Easy webinar series last May, June 2025. Before we start, I would like to mention that in the Easy Happy Hour, we basically do a quick review over the latest Easy updates. We also cover a specific Easy topic within several slides for a few minutes. And then we give the chance for the participants to share their experience, issues, problems, or any Easy related topic. I would also like to mention that this and every Easy Happy Hour session is recorded. The recording, slides, and material used during the sessions will be shortly available publicly for after a day or two. So after, shortly will be available online. For today, the highlights are Easy is now accessible for over more than 40 systems and clusters. Those are the ones we know about. Among those are five Euro HPC supercomputers. Those are Vega, Carolina, Decalion, Nostrum 5, Discoverer, and it will be available on the other four, and there is a work in progress on that. Easy is available in Gilo Winter School. It has started yesterday. Gilo Winter School is an annual event where researchers can get updated on new ideas, methods, and theories within the e-science field. Easy will also be available in the 3C Kodash EMBL. That is a data science driven event, community driven event to bring people together and share ideas and new concepts. Easy will also be available at FOSDEM. It's an open source software event, free to attend, no cost, no registration. I guess it's a pretty busy schedule for Easy. Kenneth, would you like to say anything additional about FOSDEM or any of the events I mentioned?
At FOSDEM, there will be two talks related to EASY, one by Helena in the HPC dev room, one by me in the software performance dev room. And it's in Brussels, in person in Brussels, but everything is also live streamed and recorded. So people will be able to check the recordings afterwards, if all goes well.
Okay. So those are the highlights for today. And for this session, we need to review what Easy is and what is the idea behind Easy. So for users who already know what Easy is, and for the newcomers, this will be very helpful, I guess. So the idea behind Easy grew out of several long-standing challenges in HPC, research computing, and scientific software deployments. First, there is a redundant effort everywhere, especially with the rapid expansion of computational science beyond traditional domains like physics and computational chemistry, including bioinformatics, machine learning, and artificial intelligence, which leads to significant growth of the software stack that is used for running scientific workloads. So every HPC center, university cluster, or research group needs to build and maintain nearly the same scientific software stacks, often repeating the same painful build and dependency work. Second is portability. Software that works on one system, example, Intel CPUs on Linux, might not work on another, example like ARM CPUs on same or different Linux architecture. So a problem amplified by the increasing diversity of system architectures and the growth of commercial cloud infrastructure. And third is the limited manpower that is available in the HPC user support teams that are responsible for helping scientists and scientific software users with running the software they require on high-end and complex infrastructures like supercomputers. So the easy concept is heavily inspired by the Digital Research Alliance of Canada, formerly known as Compute Canada, where they use a software stack and they share it across all major national systems. While Compute Canada primarily targeted x86, 64 Intel and AMD CPUs, EASY is significantly more ambitious in its goals. EASY is set up to be a community project by setting up services and infrastructure to automate the software build and installation process as much as possible, providing documentation and support to end users, user support teams, and system administrators who want to employ EASY, and allowing contributors to propose additions to the software stack. So, the goals or the main goal of EASY is to provide a collection of scientific software installations to work across a wide range of different platforms, including HPC clusters, cloud infrastructure, personal workstations, and laptops, without making compromises on the performance of the software. EASY environment is basically made up of 3 layers. The host OS still provides a couple of things like drivers for the network and GPU, support for shared file systems like GPFS and Lustre, and a resource manager like Slurm and so on. The bottom layer is the file system layer, which is responsible for distributing the software stack across clients. The file system layer uses CERN VMFS to distribute the EASY software stack to the client system. It's good to mention that CERN VMFS is a mature open source software project that was created to distribute software installations worldwide reliably and efficiently in a scalable way. As such, it aligns very well with the goals of EASY. CERN VMFS repository for EASY is /cvmfs/software.easy.io, which is part of the default CERN VMFS configuration since November 2023. The middle layer is the compatibility layer of EASY, which levels the ground across different versions of Linux client systems that use the software installations provided by EASY. It consists of a limited set of libraries and tools that are installed in non-standard file system location, which is called a prefix, which were built from source for the supported CPU families using Gentoo prefix. The installation path of the EASY compatibility layer corresponds to the compat subdirectory of a specific version of EASY. For now, it's 2023-06 and the latest version, which is 2025-06, in the EASY CERN VMFS repository, which is specific to a particular CPU family. Currently, we have the x86 64 and also the R64. Finally, the top layer of EASY is called the software layer, which contains the actual scientific software applications and their dependencies. It uses EasyBuild to install software, which also generates an environment module file, which is a small Lua file. And if it's a software and a dependency, it also generates several module files for each of the software applications that are consumed via L-mode, which provides a user-friendly interface to the end users of EASY. So the EASY software layer also uses RSpec, which is a small Python library that is invoked during the initialization of the EASY environment, specifically the initialization of the EASY script. Also, we use other tools like Reframe to make sure that the software built and ingested, which we will see in the next slide, will not affect the software stack that we provide. This is a slide showing the whole process, how software is built, in automatically built using the bot, then it's ingested in the S3 bucket and the Stratum Zero server, and then available to the users. So as a start, if a contributor wants to add a software to Easy, it's simply they create a PR, then people from the Easy group, specifically, we can call them, for example, the builders, will check the pull request made by the contributors. They will initiate a build process for the software in the PR. The bot, which is we call the Easy bot, will handle the build process based on different architectures. As we can see for x86, we support Haswell, Cascade Lake, Sapphire Rapids, Ice Lake, Zen 4, Zen 3, Zen 2, so on. And also we support for R64, Neoverse N1, Neoverse V1, NVIDIA Grace, A64FX. And it's also good to mention that we support generic builds for both architectures. That is, if you have an environment which is outside of what we support, it will fail back to the generic. So you can still use the software we provide, but it will not be optimized for your architecture. So after the bot successfully builds the software, we run some reframe testing, as I mentioned earlier. Then what we call the deployers from Easy will check the software that's built, and after they label the deploy label, the software which was built and set into a tarball will be signed, and then it will be transferred to an S3 bucket. From there, cron jobs usually run every several minutes to pick up those new tarballs and transfer them to the Stratum Zero server. The Stratum Zero server then checks, there is a script which checks the signature and opens a PR to the staging repository of Easy. There, another group, which we call Easy ingesters, will just make sure that everything is in control and as expected, and they will initialize the automated deploy procedure. And after that, the software that is built will be accessible by all Easy users. So this is a simple, uh, like, uh, how would I call it's not a workflow, it's a simple process maybe to show how we do things in Easy, how we add software to Easy. And it's also good to mention that it's the same procedure we apply for different versions of Easy, that is for Easy 2023-06 and Easy 2025-06. Future architectures will also hold the Zen 5, which we look forward, and also maybe Graviton 4 and 5. That's true, right, Kenneth? So we look forward to
Yep.
even support those architectures. So in a summary, what is Easy? It's an on-demand streaming of optimized scientific software installations. It works on any Linux distribution thanks to the Easy Compat layer. So basically, it works on most Linux distributions, also on Windows Subsystem Linux, and also on Mac OS using Lima, and a new way which we will be covering in upcoming Easy sessions, Easy Happy Hour sessions. It's a uniform software stack across various systems, laptops, HPC, cloud, and it's definitely a community-oriented project. So we support interaction, adding new software, sharing like your concerns, issues, similar to what we're doing today in the Easy Happy Hour. So it's a community project for researchers and users. This is what we have covered for the topic series and specifically for this session. I will not go into any demos for today. Next session will be like using the demo for what we provided today, the information running on different Linux distributions and on different architectures. You might have different questions, especially for new ones. What is, for example, the Stratum Zero server? What is CERN VMFS? We are open for any questions to support, explain, recover earlier sessions. So please feel free. If there are any questions or any clarifications you would like to have. Anything you would like to add, Kenneth, Lara, before we, or any of the participants, before we stop the recording and you can share your insights?
I'm just wondering for people who are quite new to the project, like Bert and well, I guess Renato was a bit deeper than Bert is already. But did it all make sense the first time you looked at Easy? Was it easy to go through the documentation, understand what we are doing, what the project is about? Or were there big gaps or things that are not explained or explained in the wrong way? I don't know. Any thoughts on this?
Yeah, my main idea about easy is just how are you going to keep up with all the architectures and the different combinations of accelerators and CPUs? So you get a huge matrix of maybe 3D shape, and then you get explosion in the amount. How are you going to tackle that? Because if you do, for example, CUDA, you also should do ROCm, and then after a while, maybe Intel comes up with something new, and yeah.
Even with CUDA, different compute capabilities, driver versions, and
Well, it is a problem, and we are well aware of that. We have to keep it in check so it's somewhat reasonable. What we're doing for CUDA right now is we support 3 generations of GPUs. So essentially the Volta, the Ampere, and the Hopper generations, which are the ones used in production now. And we support that for all CPUs where it makes sense. Like for A64FX, it doesn't make sense because you don't see combinations with the GPU. But in the end, I think we have 48 combinations of CPU, GPU, NVIDIA GPU that we currently support. That's a lot, but it's manageable. It's manageable because we automated that whole pipeline, essentially. So with one single trigger, we can build all those 48 builds. And as long as there's no problems that pop up with these builds, which it does happen, but it happens rarely enough that in practice it's all manageable. Whether it's 48 or 100 or 10 doesn't make a big difference, thanks to the automation.
Yeah, and then the second part is, I mean, of course, I'm a colleague of Kurt. It's like, yeah, you're using OpenMPI, and on the me, it's always a bit of a troublesome thing.
Yeah. Well, we're using OpenMPI for now, but we're already playing with MPitch as well. Especially in EasyBuild, we have a new LLVM-based toolchain, which we'll also deploy through Easy. And we have an MPitch variant of that, where we don't use OpenMPI, but we use MPitch instead. So there, we're aware that some systems prefer MPitch, or where you would like to pick up the Cray MPitch, which you can actually inject into Easy. So as long as you build against an MPitch that's API or ABI compatible with the one we used, it should be fine. So we're aware of these issues. And again, it's additional builds, that's fine. But as long as it's automated, it's not too big of a problem. And in the future, actually, there is a common ABI for MPI that was standardized, included in the new standard. So hopefully in a couple of years, it doesn't actually matter which MPI. Yeah, let's see how that works out. But that's the idea at least.
After a while, I mean, I'm already happy if you have a compiler that's C++11 compliant. So let alone be MPI compliant with the latest version. I mean, it's always something to look forward to.
So it is good points, and we're not going to lie, it is more work to install software into Easy and get it built for all these combinations. But once that is done, it works on all the systems that we support. And in the grand scheme of things, it's still a big time saver compared to what's happening today, where everybody is just building again and again on their own system. So we think there's enough of common ground and a lot of reasonable combinations that this is actually feasible.
Yeah, thank you.
It's a great question, yeah. And we're not going to, yeah, it is a challenge, but we're tackling this, I think, in a way that makes it feasible enough that we can do it. Yeah.
Yeah, Renato?
Yeah, question from my side. So I guess the support for the architectures is by design. Coming at it from a contributor side, let's say if my interest is only on a subset of these architectures, is it still possible to contribute just that, or do I need to commit to the full breadth of options?
A good question. So first of all, as a contributor, what you don't need to do is build for all these things yourself. We will do that for you. So all you need to do is express interest in adding a particular software to Easy, and then our build bots will make sure that that is built for everything, or at least you'll do test builds first. Typically, you ask essentially the bot, does it work? Does it build everywhere? And does it pass all the sanity checks and maybe the test suite that the software has? If that all checks out, we'll include it. And right now, our goal is definitely to, whenever something is installed in Easy, it should be built for everything that we support in terms of CPUs. But that doesn't mean it's your responsibility as a contributor to make sure that actually works. Maybe you've only tested it locally on x86, and you say, I'm interested in adding this. I don't know if it works on ARM. Just mention that when you make the pull request, and then we can keep close attention to it. We can give it a try. If it doesn't work, by now we've had enough experience that we probably know if it's fixable or not. If it is fixable, we'll try and take the extra step. So maybe work together with you, or either provide suggestions or give concrete advice like change this, and it's probably fine. If it's an absolute showstopper that it doesn't work on ARM, it's a significant effort to port it or whatever needs to happen in the software itself, then we can make exceptions and say we only install this for x86. But we prefer not doing this without at least looking at it and doing some effort to try and make it work on ARM as well.
Maybe one thing I can still add and could help you in better understanding. So we always aim to, as Kenneth said, to build for all architectures. But for example, what we do on our HPC system is if there is a specific package, for example, like what we saw in TensorFlow with CUDA or PyTorch with CUDA, there are some complications. We're working on solving all those for Easy, but you can build on top of Easy. So you can take advantage of what already exists in the software stack provided with Easy and build on top of that. And after some time, when things are resolved and Easy starts shipping the software you have built locally, you can automatically switch and continue using what's being shipped with Easy.
So it
Yeah.
depends a bit on how urgent things are or how much effort you want to spend yourself. Maybe you have zero interest in ARM today. Maybe that will change in the future. So yeah, but it's really being upfront and saying, look, I'm interested in adding this, and just tell us if you've tried it on ARM, if you're not able to try it on ARM, if you're not interested in ARM, whatever, and then we'll try and make it a collaboration to get it in. Yeah. Or at least to evaluate if there's any problems.
Yeah, sounds good and sounds very reasonable. Yeah, the other question that I have is, at least from my perspective, Easy is the only project of this scale that I've seen that tries to tackle the multi-architecture complexity, but also to make it, let's say, as for the end user, so that they almost don't need to care about the hardware they are running things on. However, I've seen also other efforts trying to go to some extent, not that far, but some extent. Are there attempts to, for instance, do transpilers or anything like that from other systems like Brew, Nix, even Conda? And if there's anything from the efforts that have been done to package for those systems that can be salvaged to help us package for Easy.
It depends. What do you mean with transpilers? Like taking their recipe and trying to automatically convert it to something for easy build that can be used?
For instance, yes,
Yeah.
I have some experience not with building recipes, but with transpiling, for instance, open API specifications in JSON to a full Python executable project.
Mm.
And this was quite about a kind of low-level tinkering with the Python internal assemblers and stuff like that, the abstract syntax tree. And I wondered if anything like that has been thought out or even discussed as a possible way to shortcut a bit. Because Kenneth, you mentioned automating the entire build for different architectures and so on. I wondered if something like this, but to actually port recipes from other systems, have been thought out.
Well, there's a big difference, I think, between recipes and builds. So if you're talking Conda, like pre-built Conda packages and making those work on top of Easy, I'm not aware of anyone looking at that. I think technically it will be a challenge as well. It's probably not impossible, but it may be possible for recipes. But now I'm thinking over a decade back, there were some efforts in the Easy Build community to look at recipes in other ecosystems and trying to automatically translate them to something EasyBuild could understand. So there have been people looking at this, but last time I saw this, it was a long time ago. And in the context of Easy, I'm not aware of something. What we are doing in Easy is playing with spec on top of Easy. So for example, software that's better supported in spec or only supported in spec and not yet in EasyBuild, and people still want to install this, or people who prefer spec over EasyBuild for whatever reason, but don't like it reinstalling the world, and they know Easy is sitting there and already provides a lot of things. So that we're trying to do to get spec to reuse stuff from Easy rather than building everything itself. And we've already had some early successes with that. So we are looking across different ecosystems, at least to that extent. Yeah. And I don't think it goes as far as what you have in mind, but yeah, if there's interest in that, yeah, we can see what makes sense or to what extent that will be possible or how it will be done on a technical level. Yeah. I mean, there is the complication that we want things both for x86 and ARM. Ideally, we want something optimized for specific microarchitectures as well. But there may be reasons where it makes sense to do shortcuts, or it doesn't make sense to put a lot of effort in making it fully optimal. Having something running is always better than not having it running at all, even if it's slow. So yeah, there could be temporary steps or experiments through Conda or other binary packaging systems that could make sense. Yeah, it's an interesting idea for sure.
Yeah, if I can find time, I might play around with that idea a bit. And maybe the one more question now in a slightly different direction is, I guess by now you have accumulated a lot of knowledge on how to package for different systems and so on. Are there plans to have any, let's say, best practices in terms of what developers might want to do to their software to make it easier to either include in Easy, or some kind of advices on what not to do with toolkits, software stacks, you name it?
You're advertising a talk I have at FOSDEM in 2 weeks. Do you know about it, or?
I do not. No, I do not.
Okay. I'll share it here in the chat. We can maybe even mention it in the webinar page. But I'm giving a talk at FOSDEM, which is exactly that, but in a sort of reversed way. It's a talk about what not to do and about all the bad things we see when trying to get software installed. It's not a serious talk in any way, but it is interesting and it does highlight some of the problems that we currently see when trying to install things. And maybe this could lead to advice for people who package software or people who develop software on best practices. In a broader context, there are some plans to come up with like best practices guidelines for software developers, like how do you make your software easy to install? What do you pay attention to? Like make sure they have a test suite, make sure they have somewhat clear documentation that doesn't make too many assumptions in terms of the environment in which your software will be installed. So don't always say, here's a container and that's all I will do. No, make sure that things are clear, what dependencies and all of this. So right now, there's no current efforts, but there are some things planned, let's say, that may work towards this. Yeah.
Yeah,
And
sounds good.
I think there have been some papers and maybe even webinars in this context already, but nothing coming from the Easy community, as far as I know.
Just
Yeah,
make sure
thanks.
that it's directed toward the developers, because if you tell this to users and tell them don't do it, they definitely do it. So they always try to do things that are like
I'm trying to make
Yeah.
that very obvious in my talk, but this is not real.
Yeah, I think my own experience here with helping people is that a lot of the users don't know what they are doing, so to give them advice is also the wrong target. And and from my own experience, both developing and trying to help people get set up, software is getting harder and harder to install for different reasons. And we all expect that to be the final user to take care of it. And that's definitely not a model that works. So
I think
I also see Easy being a great fit for this because it does remove that layer from the end users, that
mhm.
burden.
I think for many software developers, the end of the effort is when they tag the release and have the release notes, and then it's done. But that's the starting point for everybody else, and it's important for that developers keep that in mind. And if you want to scare people away very early on, have very bad installation instructions, and nobody will ever use your software, even if it's the best software in the world. Yeah. So yeah, there's a lot of stuff that can be done around that. Yeah, best practices, webinars, training, good documentation, and you're right. We have a pretty good view of how things should be ideally, just because we install so many things.
Yeah, I also have experience with, oh, let's write it in CMake, but then they come up with a CMake script that's horrible. So there is always pitfalls.
Know your tools is yeah.
Any other questions before we stop the recording, and then maybe we can continue what we mentioned in the earlier?
That's a nice way of making sure people join the happy hours, Richard. There's secret stuff before and after as well. It's not in the
Okay, so I'll stop the recording for now.